Welcome back in this video that we have got this resize thing properly done. Now we have the option called content details, and here we have to have this three option: density, velocity, and turbulence. First of all, I can tell you that density, velocity, fuel, and temperature, 1, 2, 3, 4. These four things is known as channels, right? So this is a channel. It's like if you say that this is channel, density channel, you're not wrong. And velocity channel, because I'll show you why I'm talking about in this way. That if I go for this fluid cache, you can see you can see we have this channels is there. So cache channel. So this is also known as channels, so that we have 1, 2, 3, 4, 5, 6, 7 channels to cache things out, right? So I'll give you the proper teaching about this caches also. But now here we can see this is density cache, density channel, you can say velocity channel, and we have color, fuel, lots of things are there. Now in this section I'm going to talk about this density. Density means is everything. Density means it is we have two things in this simulation, that we have fire, we have smoke. Density will control both of them. So if you need to have some smoke, you need to have this density. If you're using temperature for fire, then also you need to have some density. Otherwise you cannot have anything, right? So now we have this density scale. What is density scale means? Why this is important, that this is 0.5. This is a multiplier kind of thing. So if I have 0.5 and buoyancy is 1, that means is what you can tell you, that buoyancy is not 1, buoyancy is also 0.5. Why so? Because of this is a multiplier of all the option underneath of that option. So means dissipation, or maybe this pressure threshold also, this is 0.5. Because of 0.5 multiplied by 1 is going to be 0.5, right? So whatever you are going to put in here, it is going to be cut down into half. So keep in mind that whatever I'm going to use, this is also depending on your density scale. If you are using increasing density scale or decreasing, the number I'm going to put is going to be changed, right? Your look is going to be changed. So I'm not talking about that you cannot change the density scale. You can change the density scale, but according to that, you need to manipulate this thing also, right? So first of all, buoyancy. Buoyancy means is the upright motion. I don't need upright motion because of the dry ice is going to be coming downward. Downward means downside. So buoyancy is not needed. Now if I make it 0, keep in mind, extremely important note I'm going to give you, that buoyancy, if it is 0, if I go to this dynamic simulation, we have this gravity is also 0, because of if there is no buoyancy, there is not going to get any kind of gravity also, right? So though it is 9.8, but this is actually this is 0. So that means if you need to use this gravity, you have to use this buoyancy, but I'm not going to use this buoyancy at all. Now dissipation is extremely important in this case, in this situation, and we need to animate it. So that is why I have told you earlier also, make it disabled and save it. And why I need to animate it? First of all, let me do that thing first, and then I'll show you. And first of all, I need to go to 200 frame and make it 10, and right click and set a keyframe. And in the next frame, means the 201, and make it maybe 3, and right click and set keyframe. And now right click and go the first option we have here. You can see the value and the time also. So in 200 frame we have 10, value of dissipation is extremely high, and we have this like in the next frame we have 3. Why this is happening in this way? Because this is not at all an opacity kind of thing. This is a dissipation, means it is going it is vanishing with the air. Your fire or your smoke is going to be vanished in the air, right? So this is called dissipation. Now dissipation means it is not like it has to be a switch kind of thing, like Boolean switch kind of thing, like if it is 200, this is 10. If it is 200, like in the next frame it is 3. That means 3 means is what, that it is less means it will take more frame to dissipate. It will take more frames to dissipate. It is not like an opacity kind of thing, that 200 to 400, this is 1, this is 0, and it will have a gradual curve kind of thing is going to be happening. It's not like that. So it is a 3D opacity, you can say. All right. So dissipation is something very, very unique. So it has to be, you are going to use it as like a switch kind of thing, right? And why switch? Because of suppose whenever you are using any kind of thing, initially there is no dissipation. There is only we have thick smoke, right? And when it is losing the energy after some period of time, it is going to lose, or it will dissipate. So you have to give some time to it. All right. So this is extremely important, and you need to understand this thing, because of if you understand this options, then you can use this thing wisely. All right. Diffusion is not needed, and pressure threshold is not needed. This is for like big oil tank explosion or large scale smoke kind of thing. Noise is like some kind of little bit of, so this is not important. Tension is extremely important, and this is also very important, that tension force and gradient force is going to be 35. And let me tell you what is gradient force is. Gradient force is like XYZ force. XYZ, like 3 area is going to be emitting the fluid. This is what the gradient force do. Now the thing is that this is 35, but this is not at all 35. This is 17.5, because of this is 0.5. So this is 3, this is not 3, this is 1.5, because of everything I have put in here based on density scale. All right. So keep in mind this thing also. So here I have make it clear, absolutely clear, that what is density and how we are going to use this density in this simulation. The next one I'm going to show you that how we're going to get this velocity and turbulence. See you in the next lecture.